As we progress in this unit, we're going to start solving quadratic equations. And in these notes, we'll look at a pretty simple way to solve a quadratic equation which doesn't have a linear portion. What I mean by that is it only has an x squared or a squared term, and it doesn't have a term with a single x. And so we can use a square root to solve these equations. The basic process is this. We want to isolate the squared expression. Then we take the square root of both sides. And it's really important to note here that because square roots technically have two answers, a positive and a negative answer, we want to use the plus and minus here. Not at the end, but we'll use it right here in step 2. Just a quick note on that. This works because if I take, for example, the square root of 64, this will equal the positive and negative number 8, because 8 times 8 is 64, and negative 8 times negative 8 is also 64. So normally when we talk about square roots, we're just looking for the positive answer, but both do exist. And so in these particular problems, we do want to account for both answers. So that's why we use positive and negative after taking the square root. And then from there, whatever is left, if needed, we solve for x and simplify. But just remember, because of the positive and negative, we do get two solutions. We have two answers. All right, so let's try some examples. Number 1, we have x squared equals 4. And again, step 1 is to isolate the squared expression. This is already by itself, this x squared. So no need to do anything here. We just take the square root of both sides. And so x equals positive and negative 2, plus and minus 2. Because the square root of 4 is 2 or negative 2. So our solution here are the numbers negative 2 and positive 2, but we can just write plus and minus 2. Okay, number 2. 3x squared minus 48 equals 0. So here our x squared is not isolated. It's not by itself. So you can think of this as any other two-step equation. So just to kind of ignore the exponent for now. We're going to add 48 to both sides. 3x squared equals 48. We'll divide by 3. And so x squared equals 16. And now that our x squared, that squared portion, is isolated, we're going to go ahead and take the square root of both sides. And so we end up with x equals positive and negative 4. Because the square root of 16 is 4. All right, number 3. Again, this is isolated, so we can just go straight to the square root. Please remember, when you have a negative inside the radical, our answer is going to be positive and negative 2i. I being the imaginary number, which is equal to the square root of negative 1. So anytime you have a negative in your radical, you're going to get I in your solution. Okay, number 4. Again, the squared portion is isolated, so we're going to go ahead and take the square root. We get c is equal to positive and negative 5. Have to do a little work on number 5. We're going to divide to get w squared by itself, divide by 2, and w squared equals 20. So now we take the square root, and w equals positive and negative square root of 20. 20 is not a perfect square, but it does have a perfect square factor, which is 4. So 20 can be expressed as 4 times 5, and the square root of 4 is 2, and so we can simplify the square root of 20 to be w equals positive and negative 2 square root of 5. So if you can simplify radicals just like we did in the previous notes, you should definitely do that after you get your answer. So once you get your answer, double check, make sure that if it can be simplified, you take care of that. Okay, number 6. Our squared term is this entire thing. X minus 3 is all being squared. And so think of it as one big variable. And if you think of it that way, our x squared term is isolated, so we can go ahead and take the square root. So we end up with here x minus 3, because the square root and the exponent 2 kind of canceled each other out. And x minus 3 equals positive and negative 6. The square root of 36 is 6. And now we're going to solve this like any equation and add 3 to both sides. But here you have to be careful because remember this positive and negative 6 represents the numbers 6 and negative 6. And so we're going to add 3 to both of those. Okay, so 3 plus positive 6 is 9, and 3 plus negative 6 is negative 3. So our solutions on this one are the numbers 9 and negative 3, because you have to account for both the positive 6 and the negative 6. All right, moving on to number 7. We have another where we have we have an expression being squared. So we'll isolate that by dividing by 2. We can't distribute here. This doesn't work because of this exponent. It's kind of locking this together. So we have to divide by 2 to get rid of it. So we've got y plus 10 squared equals 8. And now we can take the square root now that we have isolated our square term. So y plus 10 equals the square root of 8, which can be simplified, plus and minus actually, which can be simplified. But let's go ahead and wait to do that, just to make things kind of clear. We're going to subtract 10 from both sides. So we have y equals the positive and negative square root of 8 minus 10. Just like we did with the square root of 20 on number 5, we can simplify the square root of 8 because that is 4 times 2, and 4 is a perfect square. So this is 2 square root of 2. So our solution here can be rewritten as y equals positive and negative 2 square root of 2 minus 10. Make sure you're clear about the square root kind of ending at the 2. If you want to put a little hook on it like that, you can. So this is our solution here. It's not the prettiest thing, but it is the simplified version of that solution, so it is as simple as we can get it. Looking at number 8, our square term is isolated, so we'll go ahead and take the square root there. And n is going to equal the positive and negative square root of 11. 11 has no perfect square factor, so this is all we can do. Leave it just like that. Number 9, back to examples kind of like number 2 here. We're going to treat it just like a two-step equation. Subtract 17, not 12, 17. So 3x squared equals negative 147. We'll divide by 3. And we get x squared is equal to negative 49. And then just take the square root. So x here equals positive and negative 7i, because 49 is a perfect square. 7 times 7 is 49. I times I is negative 1. And we need the positive and negative from the square root. Last problem here, we have x plus 4 all squared minus 14 equals 67. So we'll start by isolating our squared term by adding the 14 here, kind of getting rid of that. So x plus 4 squared equals 81. 67 plus 14 is 81, which is nice because that's a perfect square. So when you take the square root, we get x plus 4 equals positive and negative 9. And then we'll go ahead and subtract 4 from those numbers, because remember, positive and negative 9 does represent both positive and negative 9. So x is going to equal 9 minus 4 is 5, negative 9 minus 4, write that a little neater, negative 9 minus 4 is negative 13. So those are the two answers we get because this, remember, equals 9 and negative 9. And when you subtract 4 from each of those, we get 5 and negative 13. Okay, not too bad, pretty straightforward with the square roots. Just remember to use plus and minus after taking the square root, so that way you get your two distinct answers for each problem. And like most of these, it is just plus and minus one number, but just make sure you note that it can be two completely separate numbers depending on when in that process the square root happened. So just watch out for that.